Okay, good morning. So our next topic after arithmetic sequence, we will now be dealing with arithmetic means. So what is an arithmetic mean? So basically when we say mean, it is the average of the numbers. Like for example, if we have the numbers there, the first and the last term are x and y. Then if you are asked to solve for the arithmetic mean, or the average of your x and y, that is simply we're going to find the average like what we did in finding for the average of numbers. So say for example, if we have 1 blank 3. Now if you're asked to solve for, or if you're asked to insert an arithmetic mean between 1 and 3, that is obviously 2. Okay? And the sequence formed there is 1, 2, 3. But the question here is, how did we get 2? So, since we're talking about means here, again, mean, the other term for mean is the average. So, in order for us to solve for the average of 1 and 3, since we are asked to solve for, or since we are asked to insert an arithmetic mean between 1 and 3, what we're going to do is we're going to add the first and the last term, 3, then to get the average, divide that by the number of addends, and that is 2. So, this becomes 1 plus 3 is equals to 4, divided by 2, 4 divided by 2 is 2, therefore, we're going to insert our 2 as an arithmetic mean between 1 and 3. But how about if you're asked to solve for an arithmetic mean between x and y? Okay, so same process. What we're going to do is we're going to add our first and our last term, then divide that by the number of addends. You have 1, 2, since you have 2 addends, divide by 2, and it becomes x plus y all over 2. Therefore, the arithmetic mean that we're going to add between x and y is x plus y all over 2. Then what we're going to do if you're asked to solve for 3 arithmetic means, say x, blank, blank second, the third, and the y. So if you're asked to solve or asked to insert 3 arithmetic means between x and y, so let's simply ask, we're going to use this one to solve for this one here to get our middle term, and again use this one to solve for here. So that becomes our middle term. So let us not go deeper into this one because that will complicate things. Let us focus on numbers. So okay. So say for example I have here, in application, if you're going to insert 3 means or 3 arithmetic means between 3 and 11. So the statement goes that insert 3 arithmetic means between 3 and 11. So therefore, we're going to solve for the first mean, the second mean, and the third mean. So since we're talking about arithmetic sequence, this is still arithmetic sequence. We're talking about arithmetic sequence here. Let us not forget our formula. And the formula was a sub n is equals to a sub 1 plus n minus 1 times the common difference. But by evaluation, we can directly say what are the numbers to be inserted between 3 and 11 by evaluation. But how about if we're going to use our formula? So, what is provided for us are the a sub 1 and the a sub n, or the first term and the last term. So this is our a sub 1, this is our first term, and this is our last term. So that is provided for us. So what we're going to solve here is to solve for our d, the value of d. Since in order for us to solve for the terms here, we're going to add the common difference to our first term to get our second term, add that again to our common difference to get the third, the fourth, And to verify if our answer is correct, we can get 11. So let us solve using the formula. A sub n is equals to a sub 1 plus n minus 1 times the common difference. Again, the problem states here is insert 3 arithmetic means between 3 and 11. 3 arithmetic means. First mean, second mean, and the third mean. So we're going to use the formula. Then, what is provided for us again? We have an information that our last term is 11. Our first term is 3. Then plus, our n is the number of terms we can identify in a given sequence. How many terms are there? We have first, second, third, fourth, and the fifth terms. Therefore, we have 5 terms all in all. So therefore, n is 5 minus 1 times the common difference is unknown. So leave that as d. Okay, then let us simplify things. This becomes 11 is equals to 3 plus 5 minus 1 is 4 times d is 4d. So 4d. Then transpose 3 to the other side. Positive 3 becomes negative on the other side. Is equals to copy 4d. Okay, what is 11 minus 3? 11 minus 3 is 8 is equals to 4d. Then to solve 4d, divide this by its coefficient, which is 4. And that will be cancelled. Now, d is equals to 8 divided by 4, and that is d. So therefore, the common difference of the sequence is 2. And next question is, how are we going to use for the common difference? So what we're going to do for the common difference is we're going to add that to our first term. So therefore, the first arithmetic mean of 3 and 11 that will be inserted is added by 2 to our first term. So this is 5. 3 plus 2 is 5. 5 plus 2 is 7. 7 plus 2 is 9. 9 plus 2 is 11. So therefore, the 3 arithmetic means to be inserted between 3 and 11 are 5, 7, and 9. So, as simple as that. Okay? So let's now go to our next example. What if the question goes like this? How many numbers between 5 and 1,000 are divisible by 9? So that is now our problem. How many numbers between 5 and 1,000 are divisible by 9? So, do not worry. Since we are talking about arithmetic means, therefore, we're going to use also the arithmetic mean formula or the arithmetic sequence formula, applying with our first example and solving for the arithmetic means. But the problem here is we are asked to solve for the numbers that are divisible by 9 in between 5 and 1,000. Okay? So, let us start solving our problem with those given information. So, again, let us use now our formula. A sub n is equals to a sub 1 plus n minus 1 times our common difference. This problem is very easy. So, let us now go solve this one. So, we have now a problem that what are the numbers between 5 to 1,000 that are divisible by 9? 5 is not a number divisible by 9. 6, 7, and 8 are not numbers divisible by 9. So the question is, what is the first number that is divisible by 9? Okay. So the first number that is divisible by 9 between 5 to 1,000 is number 9. Okay? 9 divided by 9, the answer is 1. So therefore, we identify that the first term, this is now our first term in the sequence. Since we're talking about numbers divisible by 9, it means that we are skip counting by 9. Okay? So if we skip count by 9, and if the first number that is divisible by 9 is 9, what is the next number right after 9? Yes, that is 18. 9 plus 9 is equals to 18. Next to 18 is, you know what is the answer there. Okay? The next number, or the next variable that we're going to solve is the last term. Okay? The a sub n. What is the last term between 5 to 1,000, or the last number that is divisible by 9, but will not exceed to 1,000? 1,000 is not divisible by 9. So therefore, we're going to go backwards. From 1,000, next to 1,000 is 999. Next to 999 is 908. But let us go first. Let us try to divide first the number right after 1,000 in decreasing order. Okay, so 1,000 is not divisible by 9. What is the next number? Decreasing number. That is 999. The question, 999 is divisible by 9? The answer is yes. So therefore, our last number that is divisible by 9 between 5 to 1,000 is 999. But with that given information, we can now solve. Okay? Sige. Let us now solve our n. Our a sub n is 999. And our a sub 1 is 9 plus our n. Now the question here is, how many numbers between? So what is asked here are the number of terms there are in the sequence from 5 to 1,000 that are divisible by 9. So, let us leave n minus 1 as is because we're going to solve of the number of terms. How about the common difference? If the first number is 9, what is the next number? That is 18. So we now know the common difference, and the common difference is 9 also, since we are skip counting by 9. Since we are asked to solve for the numbers that are divisible by 9. Okay? So let us now simplify this one. Let us copy 999 is equals to 9. 9 times n is 9n minus 9. 9 times n is 9n. 9 times negative 1 is negative 9. Okay? And then what we're going to do next is we're going to combine our 9 and negative 9. Combining 9 and negative 9, that becomes 0. So this will be cancelled. 9 and negative 9. So what is left for us is 9n is equals to 999. To solve for n, just divide this by 9 so that this will be cancelled. This is 9 also. So therefore, n is equals to 111. So therefore, how many terms are there, or how many numbers that are divisible by 9? Between 5 to 1,000, we have 111 numbers that are divisible by 9 in between 5 to 1,000. Okay? So let us now go to our last example. Find the value of b when arithmetic mean of b minus 5 and 2b plus 1 is b plus 2. Okay, example number 3. Find the value of b when arithmetic mean of b minus 5 and 2b plus 1 is b plus 2. Okay? So let us try to understand our problem here. If we can see that our problem is a bit complicated, since these are not plain numbers given to us, but rather we are given with an algebraic expression having variables in that expression. So let us now go uh, understanding our problem here. So the first is we're going to find value of our unknown, the value of b. When the arithmetic mean, so it means that we have the arithmetic mean given. Okay? Of b minus 5 and 2b plus 1 is b plus 2. Therefore, this is our arithmetic mean of our first term and our last term. Okay? So our first term is b minus 5. Next term is b plus 2. And the last term is 2b plus 1. Okay, we have many possible ways in solving for this one. I'm going to show you the two possible ways in solving for the value of b here. Okay, the first method is we can use, let's go back first. It might be that you are confused. How did we arrive to this sequence? Let us go to our problem. Find the value of b when arithmetic mean of b minus 5 and 2b plus 1 is b plus 2. As I have mentioned, that arithmetic mean is already given. When arithmetic mean of these two terms is b plus 2. Therefore, our b plus 2 is our middle term. Our b minus 5 is our first term and our 2b plus 1 is our last term. Okay? So, if we have, let us try to put an easier example or easier comparison in order for us to solve for the value of b. Let us go to the numbers 1, 2, and 3. Okay? So, if we can solve, if you can see here, that if you still remember our first example or first illustration in arithmetic mean is we get to by adding these two terms and that divided by 2. Diba? Add these two terms and divide by 2. So we can also do it here. Okay? So we can add, then divide by 2 in order for us to get this one. So that is one way. Another way is using the common difference. But let us go first for the averaging. Okay? So we add 1 and 3. 1 plus 3 divided by 2 is equals to our mean. Okay? Our mean here is given, and that is b plus 2. So therefore, that becomes b plus 2, and this is our mean. Add first term and last term, b minus 5 plus 2b plus 1 divided by 2 to get our arithmetic mean. Arithmetic mean is already given. Okay? Then let us solve this algebraically. Okay? So, 2 will be multiplied here. So that becomes b minus 5 plus 2b plus 1. Just copy what is on the numerator. Then equals, multiply 2 to our binomial, so that becomes 2 times b plus 2. I enclose our b plus 2 because this is a binomial multiplied by a monomial. So this becomes 2 times b is 2b plus 2 times 2 is 4. Then our addition will be multiplied. Simply that becomes, since there is addition, b minus 5 plus 2b plus 1. Okay? Then, let us combine like terms. b and 2b becomes 3b. Negative 5 and positive 1 becomes negative 4. This becomes 2b plus 4. Okay? Then transpose, and also this one on the other side. So this becomes 3b transposing 2b will become negative 2b is equals to 4. Transposing negative 4 to the other side becomes positive 4. So therefore becomes 2b minus 3b is b is equals to 8. So therefore, the value of b is equals to 8. Okay? So So the value of b is equals to a. As simple as that. Okay? So that is one way. Another way, another method is by using our common difference. But we do not know our common difference. That is where we're going to use our given. Say for example, let's go back to our 1, 2, 3 problem. Example, 1, 2, 3 example. So this becomes, now take note that in our first lesson, in order for us to solve for the common difference, we're going to subtract. So before the common difference is a sub 2 minus a sub 1, or we can have a sub 3 minus a sub 2, or we can have a sub 4 minus a sub 3. As long as that is term on the right minus term on the left. So that is solving for the common difference. So for us to solve for the common difference here, this becomes 2 minus 1 is equals to 3 minus 2. Or a sub 1, a sub 2, and or a sub 3, this becomes, in order for us to solve for the common difference, a sub 2 minus a sub 1 is the same with a sub 3 minus a sub 2. Okay? So the same here, 2 minus 1 is 1. 3 minus, sorry, that is 3 minus 2. 3 minus 2 is equals to 1 also. So we're going to use this formula here. So since this is our a sub 1, a sub 2, and a sub 3, again the formula is a sub 2 minus a sub 1 is equals to a sub 3 minus our a sub 2. Why is it that we equate the two expressions? For us to solve if the common difference is really that 1. Okay? But we have solved already using our first method that the value of b is 8. Let us try to solve if we can still get the same value in using our second method or this using this formula. So our a sub 2 is b plus 2, and close that with parenthesis since there is subtraction, or a sub 1, b minus 5, a sub 3 is 2b plus 1 minus our a sub 2 is b plus 2. So do not forget your grade 8 lesson when it comes to simplification of algebraic expression. Once there is negative sign outside the parentheses, we're going to multiply our negative sign on each of the term. And that becomes negation or the changing of signs. We're going to copy b plus 2. Now this becomes negative b. This becomes plus 5. 2b plus 1, negative b, this becomes negative 2. Okay, changing the sign of our b plus 2. Then we're going to combine like terms. B and negative t will be cancelled, negative b will be cancelled. What is left is 2 plus 5. B and negative b will become b. 1 minus 2 will become negative 1. Okay? Are you following? So, this becomes transposed or negative 1 to the other side. 2 plus 5, negative 1 will become plus 1, b. And therefore, b will become 2 plus 5 plus 1 is equals to 8. So, therefore, we still have the same value of b, and that is b is equals to 8. So, that ends our arithmetic mean lesson. So, if you have queries, you can comment or PM, and you will be given a quiz right after this one. Thank you and